Hello and welcome back to Properties of Logarithms. This is a continuation of part 1. We're going to look at the other 3 properties that are listed here in this box. Now these properties, the previous properties were helped to simplify. These 3 are going to help us solve equations that include some logarithms. So if we have multiple logarithms here, we can make it into one logarithm. So we're going to be able to use this property to write it this way. So we have 3 properties. We have a multiplication property. So if we're multiplying 2 values in a logarithm, that's the same as adding the 2 logarithms together. So a product inside a logarithm is the same as adding the individual values that are the factors here. I guess we would say m times n. The factors m and n are taken, we take the logs and we add them together. So that's a sum problem. That's a sum problem of logs. So a product is a sum. Now in that case it has an equivalent exponential rule. So you may have seen this exponential rule, a to the m times a to the n power. That exponential rule is a to the m plus n. So we're taking, remember, logarithms are exponents, so we're taking these exponents and we're taking these logarithms and adding them up when we have a product. So we have a product, we're adding. So this is a very similar property in exponential form. Now the second property here is when we take a log of a quotient, a division, that's the subtraction of the logarithms. It's the difference of the logarithms. So a quotient is a difference. And its exponential property that it's similar to is this one. When we divide 2 bases that are the same, we subtract the exponents. So we're subtracting here the exponent. So this is an exponential version of this logarithmic rule. And the last one is when we have a factor to a power, that's the same as multiplying by that power. So that's the same rule as this exponential one. So when we have a power to a power, then it's just multiplying the 2 powers together. That's what we're doing here. We're multiplying the number times the exponent, which is the log. So it's a log of a power. So those are the 3 properties we're going to use to help solve logarithms. So in this process we're going to do 2 different things. We're going to expand, which means we'll get something that looks like this side here, the left hand side. We'll get something that looks like the left hand side, and we're going to expand it out, make it longer using the right hand side. So we're going to start with those. We're going to expand it out. So we're going to take this logarithm and expand it. The second thing we're going to do is we're going to take the logarithms on the right hand side and we're going to condense them down. So the 2 things we're going to do here are expand and condense. So those are the 2 things we're going to use with these rules. So sometimes we start with the rule on the left and make it look like the rule on the right, which is expanding. Sometimes we take the rule on the right and make it look like the rule on the left, and that's condensing. Alright, so let's start with expanding. So this is a product, so that means we're going to write it out as a sum. So log base 3 of 81 and log base 3 of x. We separate them out. Now, this 81 here is a power of 3, and we can use our previous rule and say 3 to the 4th power is that logarithm. So we can rewrite this 81 as 3 to the 4th power and then use the rule that we had before. Bases are the same. The answer to this is 4, the exponent. These are the inverse functions. Log base 3 and 3 to the 4th are inverse functions. They reduce each other, and we're just given back the 4 exponent there. So our answer here is 4 plus log base 3 of x. That's our solution to this simplifying. We've simplified it as much as we can, and we've expanded, meaning that it's longer than this one. We have a plus in there. All right, my second example, we're doing log base 10 of 100 plus log base 10 of x squared. Now this one, we're going to do the same thing as we did up here. It's going to be log base 10 of 10 squared. And on this one, we're going to use the last rule. The last rule says we can take the power and bring it down in front. So we're going to take this power and bring it down in front of the logarithm. So we're going to write 2 log x, 2 times the log of x. So our final answer here is going to be 2 for this part, because these are inverse functions. We're going to end up with the power again, plus 2 times the log of x. That's going to be our simplification of this problem. So we're using the rule of addition. We're also using some rules from the previous video, okay, so to simplify some of the numerical values. So we're going to do that same thing here in this one. We have a numerical value. Hopefully it's the power of 5. I think it is. When we can double check, we can verify. So this one's a division, so we're going to take log of 620, or log base 5 of 625 minus log base 5 of x. So in this case, I believe 625 is 5 to the 4th. We're just going to verify 5 to the 4th to make sure. Yes. So this one is log base 5 of 5 to the 4th power minus log base 5 of x. So this is going to reduce to just the power, which is 4. And our solution would be 4 minus log base 5 of x. Alright, our number 4th example here. This one just uses the one rule that states that we can move the exponent into the front. It's the product. So our answer here is going to be -3 times the log of a. That's our solution. We can't simplify other than that. Alright, and so in this one, he uses a similar rule, but we're going to have to first write it as a power. So anytime you see a root or a negative exponent or something like that, you want to write this as a power. And in this case, 1/3 power. So it's going to be x to the 1/3 power. That's the same as a cube root. So our rule then states we can move this down in front. So our answer is 1/3 log 4 of x for that problem. And number 6 uses several of the rules. It's going to use an addition rule here. We have a product. So this is ln of a to the 3rd plus ln of b. That's our first simplification. Our second simplification allows us to move this exponent out in front. So we got 3 times ln of a plus ln of b is our simplification of that problem. We've expanded it out to that. And here's my last example of expanding. This one uses ln, but it also has powers of e, so it's going to be ln of e squared minus ln of the square root 1 minus x. So this part of it is inverses. We're going to use the inverse. So this one is just 2. Now we would rewrite this one with the power so that we can reduce a little bit more. This is going to be 1 minus x to the 1/2 power. So we can pull this down exponent in front. So my final answer here is going to be 2 minus 1/2 ln of 1 minus x. We've expanded as much as we can. We got rid of all the exponents. We should not have an exponent on any logarithm. All logarithms that have exponents should be moved down in front. So anytime we have an exponent, there should not be an exponent in a logarithm at all because of this rule right here. This rule allows us to move the power down in front. So anytime we're expanding, we should not have a power on any logarithm. You can see all my logarithms are not with powers. All right, now the second part of this is to condense. So I have a couple of these. We're just going to work our way backwards. So on this first example, this is plus, so that's going to be times. So you're going to write log of 3 times 7, or log of 21. That's it. We've condensed that as much as possible. This one the same thing. Now we can't reduce this. 21 is not a power of 10. If we wanted an approximation, we would do log of, actually we could actually just type that one in our calculator and find out an approximation because it's a base that's on our calculator. Now on the second problem here, we're going to just take a division because it's subtraction, so it's a log base 4 of 80 divided by 5. So we would want to do that. 80 divided by 5 is going to be 16. Now 16 is a power of 4, so we can reduce this one. Up here we couldn't, but this one we can reduce. So this is log base 4 of 4 squared, which is just going to be 2 for my solution for this. So all of this right here is just equal to 2. All right. Excuse me. I have 3 more examples, or 4 more examples. This example here, we're doing a division. So this one we're going to write log base 2 of 3x minus 5 divided by x. That's our solution. We can't reduce that anymore. That's all we can do using that rule. Now this one, before we do anything, we should look to see if there's a value in front. If there's a value in front, the first thing you want to do is write that as a power. So this one's going to be log base 7 of y squared. So the first step is to move this power back up here before you do the sum or difference. So this is the sum, so it's a product, so it's log base 7 of x times y squared. This is our solution to that one. All right, this one here has both of the powers here. So we're repeating this, so this one is going to move up here, this one's going to move up here, so we're going to have ln of a to the 4th minus ln of b to the 3rd. Since it's a subtraction, we would write it as a division, a to the 4th divided by b to the 3rd. So we've condensed it down to one logarithm. All right, and my final example here does both. It has a sum and a difference, so it's going to be multiplied and divided, but they all have exponents because we have numbers in front. So the first step here is to move those powers up onto those exponents up onto the bases. So we have log of x to the 5th plus log of y to the 4th minus log z to the 8th. Now in this problem we have a product, so when we combine these two we're going to have log of x to the 5th times y to the 4th minus log of z to the 8th. Now this is going to be our denominator in this part, so we're going to end up with one logarithm. It's going to have x to the 5th, y to the 4th in the numerator, and z to the 8th in the denominator, because this minus makes division. So I combine these two first, then I combine this with its product. This is my solution. So practice these properties with condensing, putting them together into one property, and by expanding so that you can simplify some of those values. You want to do both of those using these 3 properties. And we're going to continue this on the next video in solving an equation.